So here is how we find a gradient. The gradient of a line is equal to the change of the y-axis, change of y, divided by the change of x. That means how much does it rise or fall. We can call this rise if it goes up, or fall if it goes down, compared to how much is it running, meaning going forward. So that's another informal definition of gradient: rise over run or fall over run. Now let's take a look at the picture over here. We can find a gradient by comparing any 2 points. Let me take this blue line over here first of all. So you can see if we take this point, and we take another point over here, this one. So let's compare. We can see that it is running forward by 2 unit. So it is running forward by 2 units. So this is the change in x. And it is rising by 2 unit, 1, 2. So it is 2 by 2. So the gradient or slope usually given by the letter m for this line is 1, meaning it is changing 1 unit of the y-axis compared to 1 unit on the x-axis. Now let's take a look at the red line over here. So we can again take any 2 points. Let me take this one and this one. So we can see it is running forward 1 unit of x and it is rising by 2 unit of y. That means 2 divided by 1. So the slope or gradient of the line is 2. Finally, we have a green line over here. So if I take this point and this point, we can see that it is running 1 unit, but it is falling this time. It is falling by 1, 2, 3 unit. That means the gradient is -3. We write the minus to denote that it is falling, it is decreasing, and x is increasing by 1 unit. That means the gradient is -3. So let's write down the formal definition. So the formal definition could be the gradient m of a line is y2 minus y1 divided by x2 minus x1. That means if we have a line passing through 2 points, one point has x coordinate x1 and y coordinate y1, and the other point has x coordinate x2 and y coordinate y2. In that case, you can find the gradient. Let's do a number of examples. The first example is 2 points are given, 4, 2 and 6, 3, and we have to find the gradient. So gradient equals to change of y. So this y is 3 and this one is 2. So 3 minus 2, that is the change of y, and the change of x. Remember, you have to take the value of x that you took in case of y. So here we took 3 at first, so we have to take 6 here at first, and 6 minus 4, so that would make it 1 divided by 2. So the gradient is half, meaning for every 1 unit, for every 2 unit of x, y would increase by only 1 unit. It would look something like this. Question number B. So we have 2 points. So here it would be the y is 4 minus the other y is 3. So we have to take the x here 5 minus, now this is already minus, so it would be minus of minus 1. So this would be 1 divided by 6. 5 minus minus 1 is 6. Question number C. So here we have y2 is going to be 2 minus y1 is going to be 5 divided by x2 is going to be 1 minus, this is minus 4. So the gradient would be 2 minus 5 is minus 3. 1 minus minus 4 is 5. Minus 3 by 5 is the gradient. Question number D over here. So change of y is going to be... Now I want to tell you one thing. It doesn't really matter which value of y you take first, as long as you take the corresponding value of x. So let me take this value first, minus 3. It doesn't matter. So minus 3, now I'm taking this minus 5 divided by 2. Now I have to take 2 first. Minus 6, it turns out to be minus 8 divided by minus 4, which is going to be 2. Now if I had taken The other way around, the gradient would be the same. So if I take 5 minus minus 3, because it is negative, 6 minus 2, it would be 8 divided by 4, which is also 2. So it doesn't really matter how you take the gradient.